Okay guys, so this is going to be your example problems over protons, neutrons, electrons, and all that good stuff. So I want to first off start by saying that we're going to be looking at our periodic table. So if you don't have your periodic table, you need to get it in front of you. Okay, so let's take a look at something like carbon. Okay, so 107 and it has a 6. Okay, so carbon looks like that. This number on top is what we call the atomic number. And we know that the atomic number is the number of protons. That's what we talked about last time in our atomic structure notes. This is going to be the atomic mass or atomic weight. Okay, it's going to be the same thing. So from there, we're going to, from the atomic weight, we're going to be able to tell the protons plus the neutrons. Now, the reason why they, there's decimals is because that's called the average atomic weight. And we're going to learn how to calculate that in just a second. So when we go to write this stuff, we're going to write the atomic weight on top, and then we're going to write the atomic number on bottom. It's easier to look at, and we're going to be doing some subtracting, and so you know how to do that every single time. So the atomic mass is always greater than the atomic number. Okay, so just keep that in mind. Okay, first one of our examples. So we're going to write the symbol. So the symbol for 10 is SN. Okay. SN is right here. It has a mass. We're going to round up to the nearest whole number, so that's going to be 119. Its atomic number is 50. So we write 50 down here. Now we want to find the protons, neutrons, and electrons. Okay, so our protons are equal to our atomic number. So your atomic number is 50. And your electrons are also equal to your protons in a neutral atom. So the way we get our neutrons is we're going to subtract 119 minus 50. Okay, so 119 minus 50 should be 69. Okay, so we write 69, and that's it. Calcium, the symbol for calcium is Ca. We go to our periodic table, and its atomic mass is 40, and its atomic number is 20. So we write the atomic mass on top and the atomic number on bottom. So your protons are equal to 20. Your neutrons are what we're going to find in a second, and the electrons are equal to 20. Remember, your protons are equal to your atomic number. Okay? The way we get our neutrons is we subtract this minus this. Okay, so we get 40 minus 20 is 20. Hydrogen, symbol for hydrogen is H. So we're going to go to our periodic table. Hydrogen has a mass of 1, an atomic number of 1. Okay, so our protons are equal to the atomic number, which is 1. Your neutrons, and then our electrons are also equal to 1. So 1 minus 1 is 0. Okay. Argon, the symbol for argon is Ar. So Ar is over here. It has a mass of 40 and an atomic number of 18. So your protons are equal to 18. Your electrons are also equal to 18. So your neutrons are going to be 40 minus 18, which is going to be 22. Symbol for sodium is not S, it's Na. Okay, so sodium is going to have a mass of 23 and an atomic number of 11. So your protons are going to be 11. Neutrons and your electrons are also going to be 11. So to get our neutrons, we're going to do 23 minus 11, which is going to be 12. Magnesium, symbol for magnesium is Mg. Okay, Mg is right here. It has a mass of 24 and an atomic number of 12. So your protons are equal to 12. Your neutrons are going to be 24 minus 12. Get 12. And your protons are equal to your electrons. Symbol for chlorine. Okay, so chlorine has a mass of 35.4. Okay, so we're going to round down to 35. It has 17 protons. Okay. So my protons are 17, my electrons are going to be 17, and then my neutrons are going to be 35 minus 17, which is going to be 18. Potassium, symbol for potassium is K. Okay, so we go to our periodic table. It has a mass of 39, atomic number of 19. Okay, so our protons are going to be equal to 19. Our neutrons are going to be equal to 39 minus 19, which is 20. And our electrons are going to be equal to our protons, which is 19. Xenon, symbol for xenon is Xe. Okay, it's over here. And our noble gases, it has a mass of 131, atomic number 54. So your protons are going to be equal to 54. Neutrons and electrons are going to be 54. So our neutrons are going to be 131 minus 54. So 131 minus 54 comes out to be 77. And zinc. Symbol for zinc is Zn. Okay, so zinc has a weight of 65 and an atomic number 30. So my protons are 30. My neutrons, electrons are going to be 30. So 65 minus 30. It's going to be 35. Okay? So those are pretty easy. So when it's a neutral atom where there's no charge, it's not going to be an ion. We have to, your protons are going to be equal to your electrons, and your neutrons are this number minus this number. Okay, now we're going to change it up just a little bit, and we're going to do ions. So an ion means it either lost electrons or it gained electrons. So remember that a positive charge means it lost electrons, and a negative charge means it gained electrons. Okay, so our potassium ion. Potassium has a +1 charge. Okay, with a +1 charge. Okay, it has a +1 charge because it's in group 1. We labeled that last time. Okay, so we have 39 is our mass, and 19 is our atomic number. Now, the only thing that changes whenever we do protons, neutrons, and electrons for an ion is the number of electrons. So your atomic number is 19. Your neutrons is still 39 minus 19, which is 20. Now it has a +1 charge, so it means it lost 1 electron, so this is going to be 18. Okay? So a positive charge means it lost electrons. Selenium ion. So selenium is Se. If you look at it, it's in the -2 column. Okay? So it has a mass of 79 and 34 for the atomic number. It has a -2 charge. Okay, so your protons are going to be 34. Your neutrons are going to be 79 minus 34, which is 45. And then our electrons. So a negative charge means it gained 2 electrons, so it's going to be 36. Okay, so what we're doing whenever we're doing these ions is we're taking the atomic number and we're going to be adding or subtracting from the atomic number to get our electrons. Iodide ion is iodine. We change it to an IDE ending when it's a negative ion on the periodic table. So It's in the -1 column. It has a mass of 127, an atomic number of 53. Okay, so your protons is 53. Your neutrons is 127 minus 53. Okay, so 127 minus 53 is 74. And it looks like it's got a -1 charge. So a -1 charge means that it gained 1 electron. So it's going to have 54 electrons. Barium ion. Barium is Ba. So barium is right here. It's in the +2 column. So it has a +2 charge, 137.56. Okay, so your protons is going to be 56. Your neutrons is going to be 137 minus 56. So 137 minus 56 is 81. And your electrons. Okay, so it has a +2 charge, so that means it lost 2 electrons, so it's going to be 54. Aluminum. Okay, symbol for aluminum is Al. Aluminum has a +3 charge, it's right here. Has a mass of 27, an atomic number 13. Okay, so your protons, 13, your neutrons are equal to 27 minus 13, 14, and your electrons. So it lost 3 electrons because it's got a positive charge, so it's going to be 10. Now, as you're working through this, it might be a little bit late now, but if you want to just work 3 questions and see how well you do on these, that's fine with me. Stop. Usually what I do in class is we stop at 10, we go over them, then I do a couple with them, and then they do the rest of them in that section. Okay? Now, we're going to go to the back. Okay, so we're going to complete the given chart. So it's pretty much the same thing we just did, but it's going to be in chart form. Okay, so first one, chromium. Chromium has an atomic number. So chromium's right here. It's got atomic number 24. So I'm just going to write that little 24 in there. So I can do it just like we did the other ones. Okay, so it's going to have 24 protons, 24 electrons. The neutrons, we get 52 minus 24, should be 28. And your mass is given to you by 52. Okay. Next one, your protons are 25. So that means our atomic number is Mn. Atomic number is 25. So protons are going to be equal to electrons. Now, here's the thing with the mass. If you're not given the mass, you have to do the protons plus the neutrons. So it should be 55. It might not match up to what's on the periodic table, so don't freak out whenever you see that. So your mass is going to be 55. Okay, it could be an isotope we're looking at. Okay, next one. You're given the electrons is 48. Okay, so that means your protons are also equal to 48. So 48, we're looking at cadmium, Cd. Okay, now our atomic mass is going to be the protons plus the neutrons. So it's 112. I'll just fill it in that way. Okay, 86 electrons. So that means we have 86 protons. So 86, we're looking at radon, Rn. We already have the mass is 222. Now, the way we get the neutrons is we're going to subtract 222 minus 86. And we get 136. Okay, and the last one in this section, 82 is Pb, lead. Okay, so we have 82 protons. That means we have 82 electrons. And we're going to do So write that in, 82. The mass is given as 207. So 207 minus 82 is going to be 125. Okay, so what I would do is I would pause for just a second, try and do the next chart, and check it with my work on the video. Sorry, got a little hot in here, so I gotta turn on the fan. Okay, next one. SB is antimony. Okay, so it has an atomic number. SB, where are we at? 51. So I'm gonna write in 51. So that means we have 51 protons, 51 electrons. And we're going to do 121 minus 51 gives us 70 neutrons. Okay, the mass is going to be 121. 45 protons means we're going to be looking at RH. Okay. Now, your protons are equal to your electrons. And our atomic mass is going to be 103 because we're going to do protons plus neutrons. Okay, next one, we have 38 electrons, which means we have 38 protons. So 38 is going to be strontium, Sr. And protons plus neutrons gives us our mass, which is going to be 88. Right, 88 up there. Electrons. So we got 52 electrons. That means we have 52 protons. So 52 is tellurium, Te. Okay, the mass is 127. So the way we get the protons plus the neutron, the mass is protons plus neutrons, so 127 minus 52 is 75. Okay, and then 94. So 94, we're gonna be down here, Pu, plutonium. Okay, so if I have 94 protons, I have 94 electrons. Okay, so 239 minus 94 is 145 for the mass. Okay, so the next chart is going to be dealing with ions. Okay, so we're going to have to be paying attention to our electrons. Okay, so cobalt, Co, has an atomic number of 27, so I'm going to write that in. Okay, so 27. So that means we have 27 protons. Your neutrons we get from subtraction, so it's going to be 32. And it's got a +3 charge, so that means it lost 3 electrons. So 27 minus 3 is 24. Okay, so your net charge is +3. Okay, +3, 3 plus, same thing for what you're concerned. Okay, next one, we have an atomic number of 34. So that means we're looking at selenium, which is Se. Okay, the way we get our atomic mass is going to be 34 plus 46, protons plus neutrons, so you get 80. Now, if I'm looking at selenium, the change in the electrons, so we got 34 to 36, so it gained 2 electrons, so that means it has a -2 charge. Okay, so when we're dealing with ions, we're looking at the difference in the electrons. Next one, we got 76 protons. So 76, look at osmium, Os. Okay, so it's got a +2 charge and atomic number 76. To get the mass, we're going to do 116 plus 76 is 192. It has a +2 charge, so that means it lost 2 electrons, so it's 74. Okay, next one, we're looking at number 80. Atomic number 80 is Mercury, Hg. Okay, so 80 is the atomic number. Your atomic mass is protons plus neutrons, so it's 200. And so we see that it lost 2 electrons right here. So that means it has a +2 charge. Okay. So I would pause after this table, and then I would try and complete the last table by yourself. Okay, so arsenic, okay, As, is right here. So it has an atomic number of 33. So we're going to write the 33 in there. Okay, so that means we have 33 protons. Our neutrons is going to be 75 minus 33, which is going to be 42. Your electrons, okay, it has a -3 charge, so it means it gained 3 electrons, so it's 36, and it has a -3 charge. Okay, atomic number 28 is nickel. Okay, so Ni. Okay, nickel, atomic number 28. Atomic mass is going to be 59. Okay, now its charge, 28 to 26, and it lost 2 electrons, so it's a +2 charge, +2 charge. Okay, atomic number 53 is going to be iodine. Right here, iodine. Okay, so I-53, it's got a -1 charge. Okay, so if I'm going to look at electrons, for the, well, let's go into mass. Okay, 127. Okay, so the electrons, it has a -1 charge, so it means it gains 1 electron, so it's 54. And the last one in this section. So I have 76 electrons, okay? And it has a +3 charge. So that means it lost 3 electrons. So it means we have 79 protons, okay? So that's a tricky one. So 79 is going to be gold, Au. The mass is going to be 118 plus 79 is 197. 79 like that. Okay, so these tables were a little bit different way of putting protons, neutrons, electrons. So hopefully you get the gist of how this is going. And now we're going to go on to average atomic mass. Okay, your example problems for this. So this is how we get these numbers on the periodic table. Like our first example is going to be dealing with lithium. So I should get an answer that's pretty close to 6.941. Okay? So average atomic mass is by taking the percentage of the isotopes that occur naturally on Earth and multiplying it by the atomic mass or atomic weight. Okay? So what we're going to do is we're going to take this atomic mass and multiply it by that percentage. Okay, so to convert to a percentage, you move the decimal place 2 places to the left. Okay, people mess up on that all the time. So 2 decimal places to the left. Okay, so once I take those two numbers, I'm going to multiply them. So I get 0.446313. That was 7.16. Times 0.9258. Okay, and I'm going to go 4 decimal places, and then I'm going to add down. So you get 6.9417 AMUs. So it's pretty close. Okay, so it should be really close to what's on the periodic table. If you don't show your work on this stuff, then I'm not going to give you credit for the question. Okay. So the next one, we're going to take this mass and multiply by this percentage. So I'm moving it 2 decimal places to the left. Let me do the same thing right here. Move that 2 decimal places to the left. Okay, so we're going to multiply those numbers in the calculator. $18.8762. Okay, and then we're going to add down. So we get an atomic mass of 24.3096 AMUs. Okay, and Mg, if we're looking at it, it's 24.3050. 24.3050, so that's pretty close. Okay, next one. So we're going to do 53.940 times 0.0582. I'm moving my decimal 2 places to the left. 55.935 times 0.9166. 56.935 times 0.0219. And then 57.933 times 0.0033. Okay, make sure you watch this percentage. Move it 2 places to the left. Okay, so 53.940 times 0.0582. And sorry guys if I'm going a little fast. I might be running out of space on my phone currently, so this is a little bit longer video. And I don't want it to cut off. Okay, and then we're going to add all those numbers down. I would double punch your numbers in the calculator, make sure we did it correctly. Got the same thing twice. Okay, so we get 55.8474. For iron, 55.845, pretty close. Okay, last one. And then you will have one of these on the test, so make sure you know how to do this. So we're going to take 63.929, we're going to multiply it by 0.4889, 65.926, we're going to multiply it by 0.2781. We're going to take 66.927, we're going to multiply it by 0.0411. Take 67.925 and multiply it by 0.1857. So we're moving every percentage 2 places to the left. 69.925, and we're going to multiply it by 0.0062. Okay, so we're going to multiply those numbers out. Okay. 18.3340. Now, as we're going through this, I'm going to tell you that if you get a really large number that doesn't match what's on the periodic table, you did it wrong. Okay? That means you didn't convert your percentages right. So make sure you do this correctly because this is probably going to be worth 3 or 4 points on your test. Easy question, get right. Okay, and then we're going to add down. Okay, so we get 65.3868 AMU. Okay, so it looks something pretty close to what we have on the periodic table, because zinc, 65.38. Okay, so hopefully you don't have any questions on these example problems. I'll come back in another video and do the atomic mass worksheet and the protons, neutrons, electrons worksheet. It doesn't have a lot of questions on it, so hopefully we got most of our practice in on these example problems. If you have any questions, feel free to reach out. Thanks. Bye.